Okay, now let's say we move to the second software that is known as TRBC. You can go to the Start tab on the top. You can go to the new project. So let's say you name here as practice 1. Okay, practice 1. So you click confirm. You can check on the calculation rule. So now we can use Malaysia, because if not, you cannot modify the calculation rule after clicking confirm. So now you can click yes to confirm. Okay, so basically in this TRB, we can go through the tab on the top. So basically you can see this is the start button, this is the interface, and you can go to the project setting. Okay, basically at the project setting, okay, for example number 1, you can see information here. We can write down what is the project name, and then you can check whether the project that you handle has seismic or non-seismic. Okay, so this one sometimes available for some of the country that have the seismic. Okay, so calculation rule, we use Malaysia. Here you can also adjust the floor setting. You can check on the floor height, you can check on the reference, what is the elevation. So we can use the ground floor as the reference number. This is also similar. Under the floor, under the floor setting also, you can check all the information given here. On the left hand side, these are the element list. And then since we already choose the anti-seismic grid, you can see all the information here are anti-seismic. Okay. Once you create this project, you also have to double check all the project information. For example, what are the concrete cover? So what are the concrete grade? Because this one is considered as default setting. For example, column concrete 35, non-beam frame 30. Sometimes this one is different with different project. So you can click here and change if any. Okay, so this is an example. The concrete cover also very important because it will affect the whole calculation. Let's say the concrete cover for the lower floor is 50, so you have to adjust the ground beam to 50. So this one actually, if you double click, you can change the concrete cover. On the right hand side, there are information on the anchorage. This is the information on the um, of the band or the anchorage information. Let's say for the jointing between the slab and the column, how the band should be calculated. So these are all the information of the default setting for anchorage. Okay, on the right hand side, you can see also the information of the lapping, standard information, and the length for the lapping here. For example, for this 12 meter means every 12 meter you have one lapping. So these are information that you can check at the floor setting. Okay, if you click on the calculation rule, you can see this is the standard calculation rule for the wall, for the beam. So if you double click here, they show you how the calculation for the wall should be done, and how the jointing. For example, look at this. What is the formula for the bending if we have the jointing between column and the beam? Okay, so beam column jointing. Can you see here 15D, or whether this 15D is started from the whole L shape, or maybe at the internal part only? Okay, so this is the example of the calculation rule that you can check default setting by the software. Let's say we go to the column. You can see here the top of the column. Okay, this is the number for the top of the column. If you look at on the left hand side here, this H is height and BHC actually the concrete cover. So look at the example here, 12D. So this 12D is only at the band area, whereas sometimes if you look at the outer bar here, if you have this design, the calculation rule is 12D, and this band is having this formula. So this is also something that you can check based on the drawing, whether this formula is standardized or not. Okay, because somehow you can use this inner bar. This is the general rule for the inner bar, outer bar for the top of the column, for example. If there is no changes, you can just click close. Okay, next one is the information from the project setting, where you can see the standard conversion of the bar reinforcement. Okay, I think this one everyone has commonly seen. For example, for 12 mm diameter, the conversion is 0.889. You can see here they use up to 4 decimal places. Okay, so this is the default common rebar weight setting. So after you get the length, they will automatically change in the report. The link setting that you can see in the project setting here, basically shown for the beam and column. Okay, for the column here, you can see the combination of the leg. So the leg in this software is actually referring to the main bar. For example, 2 times 2. So 2 bar on the top, 2 times 2. Horizontal 2 and vertical 2. Okay, and then for this bar, you can see the software show how the link jointing should be done. For example, if they have 4 numbers of the bar here and then 3 numbers of the bar here, then you have how many link? This is 1, that means this is 1, this is 1, and this is another one, so 3. Okay, so standard link and the link formatting is available in this software. Same goes to the beam. You can see here the legs of the closed link, legs for the open link, and torsional link for the design of the beam have been also incorporated in this software. Okay. So next one, under the project setting, you also can see the information of the link. This is what we have seen before. The bend and the hook calculation also have been shown here. This is the standard formatting. You can check and please double check. And then the information of the tension compression setting. This is the standard. For example, T is referring to tension anchorage length. C is referring to compression anchorage length. Okay, and then for the lapping, they already mentioned what is the standard calculation rule. And then on the left hand side, the guideline of the software already identified what's supposed to be the category of the anchorage. For example, okay, let's say we look at one RC wall, horizontal distribution bar. This is under DAL, so they are calculation reference that you can see in the anchorage earlier under RC wall anchorage format. That is the information that you can see on the project setting. So right after you see all this adjustment for the project setting, you can click on the beam model. Then we can start import the model. Okay, if you already finish all the modeling from the TS, you can import from the model. So when you click on the beam model, import model, you can see there are 4 steps that you have to fulfill. Okay, so the first one, you have to select a model file from the folder that you have seen. So which file that you have to import, make sure you import the file in cubic file that you already create in the DS software. So after you import and click the file, you select the model file, you can click start. So what the software will do after that is to carry out the match setting. They will do the adjustment if any. Now, just now in the TS model, we only have one zone. So you can see here there is one zone. There is no second and third floor, for example. So they will carry out match setting. Let's see the information given by TRB is 4 meter story height and TS is 3. Which one you want to follow? Make sure you follow the original cubic file that is 3 meter. Follow the TS information. So what you have to do next is to click on the next tab. The software will ask you what scope or import the scope that you would like to copy. Maybe you would like to copy ground floor only. So here, for our case, we copy all the floor list. And then you can see here TS element category, element type after, and whether we want to import everything or not. So for our case, we import everything and then you can click next step. Okay, so the last one will be finished. Then you can see importing completed. Okay, after that, you can just click on finish. So once you click on the finish, you can see the models already there. But if you try to move the model in 3D, sometimes you can see it's a bit hard and it is not really smooth. So the suggestion made by Loden software is for you to go back to the start button and then you can close this project. Okay, you can close this project if you can see the movement is not good. If let's say if you go to the dynamic function and then if you move your mouse, you are not be able to move the mouse properly. Okay, so this is the same view that you can see with the TAS. This is the dynamic function. If you want to go back to the 2D model, you can click on this model. So basically, these are the these are the tab that you can see on the top, the start button, the project setting. Then we will import the file. On the left hand side, we have the element navigator. So now let's say you would like to measure for any item related to the, let's say, slab. So make sure you choose the correct floor. Okay. So after this, we will go to the modeling for the TRB for the next element.